All right, welcome. IS 401 class on database normalization. Oh, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Thank you so much for being here. This is about the right size of class. This is the size of class I wish that the core was all the time. Just 10 to 12 students. I would be able to learn your names. Oh my gosh. Oh. And I could call on you. All right. So today we're talking about normalization. It's amazing to me to think that this is still relevant. This is something that was invented 50 years ago in technology, and it is still relevant today. So let's talk about what normalization is. Come on in and have a seat. So normalization is a procedure to structure relational data to avoid common problems. Now, it turns out that and there's all kinds of different normal forms. So we're going to talk about first normal form, second normal form, and third normal form. These are the ones that's kind of generally accepted. If you're not in third normal form, which assumes the two prior normal forms, your database is in serious trouble. There are higher normal forms. There's one called fourth normal form, Boyce-Codd normal form, fifth and sixth normal form, and they are dealing with really strange deviations, kind of really strange little tiny things. And so we're not going to worry about those. We're going to get to third normal form. But here's the good news. If you have built your domain model class diagram correctly, or you're modeling the domain, then I'll teach you the rules that you go step by step to convert those diagrams into table structure. They're automatically going to come out in third normal form. And so in terms of just saying, what do I need to know about normalization to be good at development? Probably not a whole lot, because if you do it right, if you model it right, you get the modeling right, you'll be in third normal form automatically. But where this still becomes really important for you as information systems data professionals to know is that when you look at someone else's database and you say, wow, this is really bad. It's not a very compelling answer to say this is bad because it's not the way I would have done it. But if you can point at something and say, you see that right there, that's a partial dependency, which means you've got a violation of second normal form, which are the standards about how we design relational databases, then the person you're talking to goes, oh, okay, we better fix it. And so, that's the big reason that I want you to learn normalization, is so that when you're talking to someone else's and you can say, oh, this is a bad design, you want to be able to say why, and to sound like you know what you're talking about, and that's going to be good. So it turns out this term, common problems, we're not going to use that term when we're talking about problems in data. We're going to use a word, anomalies. An anomaly is just an undesirable situation. It's a word in the English language. We rarely use it, except when we're talking about normalization. For whatever reason, that becomes the term. Instead of saying problem, we say anomaly. And we'll see us use that. Okay, so this was originally proposed in 1970s, so now more than 50 years ago, by a guy named Edward Codd. He went by Ted. It was Ted Codd to those who knew him. I didn't know him. I never met him. But he was an employee at IBM. So he was just at IBM. He wrote a paper that was called a relational model for large data banks. Didn't even use the term database back then in 1970. And in that, he proposed the relational model, which is the model that we use every time we're using MySQL, the SQL Server, or the underlying model behind all of that. So Codd was the guy who wrote it. And that name is coming here on our first slide, and it will become important again on our very last slide. So remember that name, Codd. Okay, so first normal form. It's like the baseline, the basics of getting our data structured correctly. In fact, if your table isn't even in first normal form, it's not even a table. It's so bad. I mean, a relation means you're in first normal form. And so if you're violating first normal form, and we'll show you the common ways to violate first normal form, it's not even a relation. And I'm going to use the term relation for table here, just to be kind of consistent with the way this is normally talked about. So when I say relation, you're going to think table. That's just a mathematical word for table. So you probably want to think of it in that term, but we're going to use the word relation here. Same thing for column. I'm not going to use column. I'm going to use attribute. So this is the relational lingo. A relation is a table. A column is an attribute. A row is a tuple. So we won't be talking about rows. We'll be talking about columns and tables. So I'll use the term attribute and relation. So a relation is in first normal form if all of its attributes are atomic. So what does this mean? It's like nuclear energy or something? No. Atomic just means it can't be split up anymore. So yeah, atomic attributes. And when I say they can't be split, of course, a name could always be split into its individual characters. But the question is the way that you split it still meaningful in your business domain? So if we look here and we ask author ID, can author ID be split up? It's like 5 digits. Could it be split up? Yeah, you can split into a 1, a 0, a 0, a 2, and an 8. But do those individual parts mean anything in the context of the business? No. And so author ID is atomic. Can't split it. Okay. So how about name? Is name atomic? Yes. Here's name. Look at it. How might you split name?
First and last name?
Okay. Now, if you split it into first and last name, the question is, does this last name have meaning by itself in the domain that we're working in? Would we ever want to say, you know what, I'm just interested in the last name for this? And if you're saying yes, then you're saying, that is a non-atomic attribute. So this is going to be a violation of first normal form. So this table is not in first normal form because we've got non-atomic attributes. Also, they're called multi-valued attributes, an attribute with multiple values in one cell. And you say that's a violation of first normal form. Okay, so we're gonna fix name. I'll show you how to fix it. How about phone number? Is phone number an atomic attribute?
Yes.
So you're saying yes pretty quickly here.
I mean, you could use the first 3 digits, that's like the area code.
Yeah. So what you're saying is that the first 3 digits here are the area code. And so depending on what we do with the phone number. Now, if this is like a database, like the phone company is running, they're probably going, oh yeah, actually probably all 3 parts of this are meaningful subsets. You've got the area code, this is called the prefix, and this is called the exchange, I think. Anyway, there's names for those different parts. And if you're really dealing with telephone numbers, on that level, to where you're kind of you're talking about how does an area code map into geographically, then that probably is going to be a non-atomic attribute or a multi-valued attribute. But if you're just saying, we've got to call these people occasionally, and we need to know their number, and you're probably going to say, you know what, we probably don't ever need to split that apart. And so whether it's atomic or non-atomic depends on the domain. How are you using the data?
And that was basically, yeah. It's depending on your use case.
You cannot just look at it and say, that's clearly a non-atomic attribute, or that's clearly atomic, because it depends on how it gets used. Absolutely depends on how it gets used. Okay, so I think, for most business domains, we're going to treat phone as an atomic attribute. Now, on occasion, would you say, you know what, I'm interested in calling people, with a certain area code. Now, it used to be that the area code told you what a part of the country the phone was in. Is that true anymore?
No.
No, so it even becomes less valuable to us as an identifier. You might say, I'm interested in calling people in the San Diego area. Well, 760 is the area code for folks down there. And if they're a landline users, it still is, but landline, who uses a landline? Some people do, but it's becoming less. So the area code is now kind of less information bearing than it was like 20 or 30 years ago. So we're going to treat phone as an atomic attribute. It's the way it is. Okay, so this is the main reason that we want to get rid of non-atomic attributes. We would like all of our attributes to be atomic. And that is, let's say we got this query, show authors with the last name of King. So because last name is not its own column, I've got to do all kinds of jumping around to be able to get last name to be identified individually. And it's not terrible in this case. But I've got to say, all right, I'm interested in I'm dealing with the name attribute here. So I got the name attribute here. Let me go ahead and switch on my laser pointer. So I got my name attribute here. And so, but I just need the left. And so I'll use the left function of the name attribute. Well, how many characters do I want off the left? Well, it depends on where the comma is. So I got to ask where the comma is in the name attribute. And so, that's going to tell me 5. We're looking for King here. But I'm not looking for the 5 characters. I'm looking for just the first 4 characters when it's King. So I got to subtract 1 off of that to give me the expression that tells me how many characters there are on the left equal King. And then that gets me there. So you can see that it's not as nice a query as if they were non-atomic. Then we could just say, the value that we're after, equals King. Okay. So you might guess, you could probably figure out how to do this one all on your own. Make a new column, call it first name. I'll move the first names into that column. I'll get rid of them and call the other one last name. So it's just going to split, just kind of a horizontal split. Now, querying this is going to be a lot easier, right? Just where last name equals king. So this is the main reason? This is probably the main reason, maybe not the only reason, but this is the main reason that we really want to have our tables in first normal form, because it makes it easy for us to work with the data. So any questions so far on kind of looking at splitting something like first name, last name? Pretty straightforward. It's going to show me on a scale of 0 fingers to 5 fingers. 5, I totally get this. 0 is, am I in the right class? Wait, isn't this a marketing class or something? You're 405. Okay, so that's good. Let me see. All right. Now let's look at pen name. So we've got author ID, first name, last name, and pen name. So Theodore Geisler's pen name is Dr. Seuss. What do you think? Is pen name an atomic attribute?
I'd say in this case, yeah.
Oh, okay. You jumped there pretty quickly. Yeah, I think so too. I mean, I could totally say, you know what, let's sort our authors by last name. Let's write an email to our authors that, you know, addresses their first name and says, you know, hey, Maurice, where's the manuscript or whatever. But I don't see us needing to split the pen name now. Could be that someone who's really in this industry would go, oh yeah, you totally need to. But I think, right, I think for us, we're gonna say it's that'll be an atomic attribute. But turns out Theodore Geisel has got more than one pen name. Stephen King's got more than one pen name. And so now what would you say? Is pen name now an atomic attribute? Yeah, so now this is something we got to deal with. All right, so let's take a look at one possible solution here. I'm just going to take that pen name and I'm going to split it up into multiple columns. Pen name 1, pen name 2, pen name 3. You're shaking your heads. Oh, don't do that. First question I want to ask now is this table in first normal form? Yes. Yeah, this table is in first normal form. There are no multi-valued attributes. All of the attributes are atomic. Now, when Codd was writing the paper, he actually used the term repeating groups. So we want to make sure there are no repeating groups. And that has been used to say, well, you really do have a repeating group here, but technically this is not a repeating group. These are just individual, they just happen to be named the same thing. They really are the same kind of data, and there's a whole bunch of reasons why this is bad. And I'm going to convince you this is a bad way to put a table into first normal form. It sounds like most of you don't need any convincing. You're already there with me. Let's look at some of the issues. Okay, so I went there and immediately some of you were shaking your head. So why? What's wrong?
Well, let's say we have 4 pen names, or let's say we have 12.
Okay, we get some new author that's got multiple pen names, more than 4. We got to change the structure of the table to accommodate the data. That's terrible. Another comment, or was that the comment?
I was going to say the same thing.
Same thing. Any other thoughts? Yeah, go ahead.
There's just a bunch of empty cells.
Oh, a bunch of empty cells. You know, you're right. Now, what do you think? Does, like, when I store this in a kind of typical relational database technology, when I store this, does it actually use data to store these empty cells?
I don't know.
The answer is yes. Yeah, it totally does. One of the ways that makes relational database fast, and we'll talk about this later in the course, but is being able to have a fixed record length allows you to jump to different parts of the data structure very, very quickly. And so we'll say, you know, we're going to say this is 10 characters long or 12 characters long. We're going to store 12 characters, even if there's nothing in it. And depending on whether we use that's for sure if you use the char data type. Varchar is not quite so clean as that. And so some of it gets, there would be kind of part yes and part no. Okay, but, and for sure, back when Codd's writing in 1970, removing duplication out of the database so that you save storage space is a concern. Maybe even a major concern. Why? Because disk space is crazy expensive, crazy slow, and we're worried about having too much data to fit onto a disk. Right? And so, yeah, but today, what is it? Is disk expensive? Is disk storage cheap or expensive?
I mean, if it's just a hard drive, it's cheap. SSDs more.
Yeah, it's crazy, crazy cheap. In fact, could I spend a couple of days trying to design this to save? You know, how much data would I have to save? How much data space would I have to save to be worth spending a couple of days figuring out the right way to do it?
A couple terabytes, maybe.
A crazy amount of data. Just because my salary for a couple of days as an information systems professional, it's gonna be like, you know, I can buy like an 8 terabyte disk for $100. Today, 8 terabytes, $100.
Yeah.
How am I going to save? Hopefully I'm making more than $100 a day. No, hopefully I'm making $300 or $400 a day, $500 a day. You see the argument here? So we're really interested in reducing those data anomalies, which I haven't shown you yet. Originally, we're trying to save space. We're not really trying to save space anymore. You know, if we could use up a little extra space and get all the benefits here, we're totally for that because storage is cheap. Okay, let's take a look at a particular query. Simple query, give me a list of authors with their pen names. Okay, it's not so bad. So I have first name, last name, pen name 1 as pen name from author. But then I'm gonna have to union that, bring the data from pen name 2 and pen name 3, and then sort it. That's gonna, now I'm having to say, I've got the pen name information is split out across three different columns. So I got to do something to kind of bring those all back together. What do you think? Is that a nice query to write? Job security, I guess there. Query is going to be difficult. So yeah, but can you do it? Yeah, you can totally do it. You can totally do it. Oh no. Oh no, what? What? Oh no. Theodore Geisel has 4 pen names. He's also known as Theophrastus Seuss. I don't know what he wrote as Theophrastus Seuss. But yeah, you've already identified this, is that, oh wow, we've got to now change our data structure to be able to handle someone, and who's to say that someone's not going to show up with 10 different pen names. Just think about, but it's not just the structure of the table. Now my queries, because I've now taken what used to be stored in 3 columns, I put it in 4 columns. I got to adjust, little frowny face. Oh, what's that? I now got to adjust any query that deals with pen name because pen name is no longer isolated to those 3 columns. And it'll give me the same result, but now I got to deal with pen name 4 as a separate query. So even though technically that table is going to be in first normal form, it's a really bad first normal form. Okay, so let's take a look at this differently. So I've kind of gone back to where even I've left name as a non-atomic attribute or a multi-valued attribute. There is something fundamentally different, and we solved pen name the same way we solved first and last name. We split it horizontally. We just had to make a column for every value and call it good. But there is something really fundamentally different between name and pen name. Kind of at a low level. I mean, yeah, one's a made-up name. I guess all names are made up. But anyway, one's a legal name, one's not a legal name. I'm not talking about that. I'm talking about kind of even lower, more general. What's really different between the multi-valued attributes that are in name and the multi-valued attributes that are in pen name? Yeah.
Cardinality.
Cardinal. Oh, you're saying here there's multiple ones of them, but there's 2 here. There's 2 values here in this multi-valued attribute. There's there's 1 value here. So you're saying, yeah, maybe this one's always 2, and this one is, well, sometimes 0, sometimes 1, sometimes more. So this is like, many. So this is, maximum cardinality constraint over here is 2 or something. Okay, so yeah, that's something that's different. I'm looking for something else kind of along those lines that is really, really different. Go ahead.
Well, a pen name doesn't have to exist for each author.
Oh, so okay, so may not exist. I think that could be true for something similar over here. Yeah. Actually, do we ever have people with no names?
Unknown is usually what they do, right?
Well, you might, but what do you think? Do we ever have people who never get named?
Well, you have like a company that publishes something, right?
Oh, yeah, company. I'm talking about human beings. Are there any human beings with no name?
Yeah.
Who?
Newborn babies.
Newborns, and especially some that die young. If they die, just shortly after birth, quite often they're not named. Maybe today we would tend to name them, but you roll the clock back a couple hundred years, you're not naming a child that doesn't live longer than a day. Because that's a good name. You like that name. And you'd like to use it on the next, for the next child. So I can imagine situations where we even have these are blank. It'd never be a different context. Probably people with no name aren't writing books. But
Well, I mean, there are books that are written that we don't know the authors.
there might be books that we don't know. So yeah, that could be interesting. Yeah. So yeah, that's different here. The thing that I want to point out that's fundamentally different here is that this is a multi-valued attribute, right? A non-atomic attribute, but the 2 values here they're different stuff. This is a first name and a last name. So when I'm talking about what are these attributes, I can say, oh yeah, they're different from each other. But over here, this this non-atomic attribute has 3 of the same stuff. And it's that difference that's critical as to how we handle it. If we say, well, we've got like kind of 3 different columns squished into one here, they're all 3 different kinds of data, just make those into individual columns. But this is really different because this is an arbitrary number of the same kind of stuff, and that one we're going to treat differently. So in this case, instead of taking pen name and splitting it out into 3 columns, I'm going to make a new table for pen name. The primary key is going to be the primary key of whatever table it came from. So over here, primary key is author ID. I'm just showing primary keys in blue here. So over here, primary key is author ID. Primary key will be author ID here as well. But then my multi-valued attribute will also become part of the primary key. So, I mean, does it make sense for us to say that over here, that Dr. Seuss, that Theodore Geisel has a pen name of Dr. Seuss and has another pen name of Dr. Seuss? Does it make sense? I don't need to say that. And so that's why I'm going to make this the composite primary key. Okay. All right. Questions here?
Can I see it together, if that makes sense?
Yeah, we'll do that here in just a second. Yeah.
About author ID 10029.
Oh, let me get there.
Okay.
So I just want to point out that we're getting to all, right, just showing that we got the reference, right? We've got all 4 of Geisel's pen names here. But yeah, you're right. This is an interesting one. Here, what we're saying is that Sendak doesn't have a pen name. And so we've got a blank row here. And I think you're saying, well, what do we even need that there? And the answer is we don't. So now we don't have that blank column for when there's no pen name. So it's kind of nice because we're using less data. Well, we're using a little more data here because we have to duplicate the reference here.
It should be quicker, right?
So the question is, it should be quicker. And the answer is, I'm not sure that it's quicker. I'm not entirely sure that it'll be quicker. But let's go ahead and get to the query then that we have for this one. So but first, before we look at what this means to query, general thoughts about this approach. Comment?
So I feel like if you were, like, it's probably useful for almost all situations, unless you wanted to like know the pseudonym that they wrote the book under, right? Because then it wouldn't be like linked directly to that.
Ah, okay. Yeah, now, so here what you're saying is that, well, we've got, how are we going to actually tie this onto a book? Right? We could tie this to an author, but how do we know which?
But you said pen name's also a key. So can't you use the pen name as a key and connect it to the book?
In this case, sure. The foreign key that we would put in there would be the author ID and the pen name is how we refer to that to a book.
Yeah.
But now you're saying, oh, we've got a composite primary key here. Maybe we'd rather have that as a single key, and that's okay. That's a different question than we're trying to wrestle with right now. But yeah, certainly another approach would be to say, let's just make another ID for this, and then we don't have to have a composite primary key. But then, yeah, I have to give some more thought to that in terms of actually how you'd work that out. Okay, let's kind of go back to our old query. We push this into multiple columns, this multi-valued attribute into multiple columns. Here then is the query when we split it into 2 tables. Because now our pen names are all sitting in one column here. And so I don't have that awkward thing of saying, we'll take first column, we have a second column, fourth column, and kind of merge them into one column. It's a little more complicated because we do have to do the join. Our other query had no join involved. But I mean, I think you look at that and go, which one is better?
That one.
Yeah, and just in terms of kind of readability and maintainability, this one's better. And of course, this one has the other that problem of saying, well, if we have to add a new column, we've got to come back and modify the query. We get someone who comes up to us with 20 pen names, great, put them in the database and we're ready to go. Okay, that's first normal form. So a summary is first normal form, all the attributes in the relation are atomic. And so how do you deal with non-atomic attributes with different kinds of data? Just split them into individual columns. If it's a non-atomic attribute with the same kind of data, you're going to make a new relation for the attribute and use a composite primary key. That would be kind of the first step. And you can decide later if you want to change the primary key of that table, kind of how it links. First normal form, down 2 to go. Okay, second normal form, the relations in second normal form if in first normal form. So you got to get first normal form for, you can't be in second normal form if you're not in first normal form. Okay. And it has no partial dependencies. Okay, so what's a partial dependency? Let's even back up. What's a dependency? Let's get to what a dependency is. I'm going to give you this description of a dependency. Stick with me because this will be hard to understand. We'll go through some examples. We've got two attributes. We've got attribute B. It's going to be dependent on attribute A if for a given value of attribute A, there can only be one value for attribute B. So we're talking about looking at an attribute and saying, if I know the value of this attribute, what are the possible values that could go into this other attribute? And if I say there's only one, then we say there's a dependency. Let's look at some examples. Oh, and so, in fact, you remember back in like pre-cal or pre-algebra when you were learning about what a function was. So a function, you can put in any number of values into a function, but the function is going to give you how many values out. Function always gives you a single value out. And so that idea of a single value is, these are sometimes called functional dependencies. And more loosely just called dependencies, but the full name is a functional dependency. And abbreviated FD, incidentally. So when we say FD like this, you're talking about, that's what that means, a functional dependency. Okay, so I'm asking the question here, is first name dependent on last name? Or another way to say that same thing, does last name determine first name? And I'm showing those both down here. We'll have several examples here, and I'm giving you both ways to say this. Does last name determine first name? Last name determine first name? And is first name dependent on last name? Oh, yeah, you're answering the question. I'm still trying to make sure you understand the question. By the way, so does last name determine first name? In this case, last name then is referred to as the determinant. Does first name depend on last name? This one is the dependent. We have those two terms. The determinant is the one that infers what the other value is in a functional dependency. And the one that is, when you say, oh, there can only be one value for that, that would be the dependent. Okay, so question, it sounds like you're saying no. And that's right. So we say, does last name determine first name? That would mean for a given last name, there can only be one value for first name. And here, for a given last name King, we've got two values for first name, Lori and Stephen. And it's not just, does there happen to be two different values for a given last name in this table, but it means in the domain. If I know the last name, could there be two people with a last name that have different first names? And if so, it's not dependent. Okay, so it's never just looking at the data that you have, but it's the domain the data is from. If I know the one value, am I sure to know the other value? Okay, so the answer is no. First name does not depend on last name. Also say it, last name does not determine first name. Okay, does first name determine last name? Yeah, so we've got first name Stephen with the last name of Kuhn, so first name Stephen with the last name of King. There's no dependency there. Does city determine state? If you know the city, do you know the state?
No.
You're saying no so fast, are you sure?
Yes, there are multiple cities named, fill in the blank, Arlington. There's
Sure, Arlington, yes. So we got a couple of folks are from Arlington, Virginia, but we also have an Arlington, Texas. Now, do we have any cities where we say not just the name of the city, but a single city is in two states? So if it's not just the value in
Kansas City?
Kansas City is a pretty good, because you've got Kansas City, Kansas, and Kansas City, Missouri. How many mayors are there? Two mayors, yeah. So I think in the United States, there is no single city that's in two different states.
Okay.
One metropolitan area.
Yes.
But here, when we're talking about a functional dependency, you were talking about the value in a column. And so does city determine state? The answer is no. Does city determine zip? If you know the city, you know the zip code.
Not necessarily.
Not only not necessarily, but not by a long shot. Like in large cities, you got multiple zip codes. Provo's got at least two. My next door neighbor has a different zip code than I do.
Really?
On the board. But of course, even Arlington is in a different state, so it's not going to have the same zip code. So no, are we ever going to find one that actually is true here? Zip determines city. If you know the zip code, you know the city.
Oh, maybe not.
Here we've got 42223, Clarksville, it's one zip
Yeah,
code. What's a zip code? It's an identifier for a post office.
yeah.
We've got a post office that serves a couple of small towns. One single post office that serves a couple of small towns. So no, zip does not determine city.
To state.
Zip determines state.
Yes,
Turns out Clarksville and Oak Grove, two small towns right on the border.
really?
And the reason is because, you know, it's a post office. Are we gonna, we're gonna have two different post offices here because they're two different states. Those are two small towns on the border. One post office is enough for both of them. So zip doesn't determine state. I'm starting to think there's no functional dependencies ever. Does author ID determine last name?
Yes.
Yes, you got there pretty quickly. The author ID is the primary key, which means I cannot have any duplicate values here. So for a given author ID, there's only one place to put a last name. There's only one place. The primary key always determines every other attribute on the table. It has to by definition, because you can't have two values in the primary key that are the same. And so every other column only has one place. If you have no multi-valued attributes. If you had a multi-valued attribute here, then an author ID, you could have two last names in here. One author ID could have two different last names. It wouldn't be, but remember, it can't be in second normal form unless you're already in first normal form. So by the time we're here asking questions about second normal form, there are only atomic attributes. Ah, yay, we finally found one. Author ID determines everything else. So does it determine last name? Yes. First name? Yes. City? Yes. All of this.
In this domain.
In this domain, yeah.
Right, I mean, you could have like an author with multiple addresses or something like that, so.
Well, yeah, but this is an identifier.
That's what I'm saying, like an author in the.
Oh, it could be in multiple cities.
Right, but in this domain,
That's right.
it does.
And it's because this is a column in this table. It's an attribute in the relation.
Right.
And because there's no multi-valued attributes at this point, it has to be functional. Okay, so that's a dependency. What's a partial dependency? Partial dependency exists when we have a non-key attribute that depends on only part of the primary key. Meaning that you've got to have a composite primary key to even for second normal form to even be a question. So if you're in first normal form and there's no composite primary key, you're in second normal form, period. Okay, so let's take a look at this. So let's suppose now that we've got a book table here, where we're looking at like physical copies of a book. So I've got copy number 1 and copy number 2 of a particular ISBN. So here's Green Eggs and Ham, same ISBN, a couple different copies. One's in excellent condition, one's in good condition. Okay, so this is our table. Does this make sense as a composite primary key here? Yeah. That's a pretty good composite primary key, I like it. Okay, so does ISBN determine title?
Yes.
You know the ISBN, there's only one possible title.
Yes.
We look here and we say, yeah, well, you know, we kind of look over here and say, oh, we'll talk about how they're going to steal Christmas on a later screen. So yeah, if I know the ISBN, there's only one title for that ISBN. Okay, so this is a functional dependency. This is a partial dependency. It's functional dependency because ISBN determines title. It's a partial dependency because the determinant is a part of the primary key. Questions? Go ahead.
But also copy number, you couldn't use copy number to determine the title because you've got 1 and 2 over there too.
Yeah. Does copy number determine title?
No.
No. But ISBN does. Oh, are you? But yeah. And of course, taken together,
Right.
they have to determine title. Okay. So the point here is that this is what a partial dependency looks like, where we say, oh, we've got a determinant that's a part of the primary key. We've got an attribute over here that's a non-key attribute. And yeah, it determines there's a functional dependency there. Okay, so this one's not in second normal form. So title depends on ISBN. What else depends on ISBN?
Author ID?
Author ID depends on ISBN. What else?
I don't know if format does.
Format depends on ISBN.
Okay.
Yeah, if the format, I'm pretty sure about this. Format determines part of what the ISBN says is what format. So if you have a paperback book that's exactly the same, otherwise it's a different ISBN. I think.
Well, in this one, That's true for the How the Grinch Stole Christmas.
Oh, yeah, because if you look at the second one or the third one, it's paperback and that's. and-
Right, yeah, so we got this ISB, in fact, we'll look at that. No, here. So, yeah, but we're not going to trust this data too much because this is data that I put together. I've made some kind of conceptual mistake here. Looking at this is not going to prove anything. All right, so there's a naive solution to this. If you want to get any table into second normal form, what could you do? Just make a new primary key. It has to be in second normal form now. Yay, we're in second normal form. It's called, I call it, it's not like the naive solution. That isn't like a general term in the world of normalization. This is me saying, this is what kind of a beginner at this might say. We're trying to get in second normal form. Okay, what have we given up by saying, wait a minute, we're not going to have this composite primary key?
Well, do we even need copy number now?
Well, oh, that's a good question. So, yeah, I don't know. Maybe we don't even need copy number. We could throw out copy number, just use ID. Yeah, so that's kind of one thing to think about. But if let's say we did need copy number, maybe this is like the kind of the sequence in which the copy came. So when we get a new book, a new copy of Green Eggs and Ham, it'll be copy number 3. When we retire book number 1 because the dog ate it, that's still going to be gone. We'll then have only copy number 2 and 3. So if we did need that, we've lost the constraint in here that says I can't have 2 copy number 1s of ISBN. We've given that up. Now, could we put that in as another additional constraint? Yes, we could, but we've lost it from the primary key constraint. Now let's go ahead and talk about what some of those anomalies are. Okay, so has this naive solution fixed the problem at all? Let's take a look at what some of these are. Okay, so an update anomaly is when we get a bad situation in our data because of an update. So let me go ahead and update one of these titles. Instead of Green Eggs and Ham, I'm going to kind of errantly put it as Green Ham and Eggs. In fact, if you look at the picture on the front of the book, ham is green too. This might be a better way to, might have been a better title, I don't know. But now, here's the problem. For a given ISBN, it's possible for me to have 2 titles.
Oh.
Functional dependency says, and the dependency here is that if I know the ISBN, there can only be 1 title. I know that that's the functional dependency. And with this structure, it's possible to say for a given ISBN, I've got multiple titles. That's an anomaly. That's a problem. Because it should be that a given ISBN only has 1 title. So that's an update anomaly. It's our data went bad. How did it go bad? Because we updated something. Okay, here's a delete anomaly. This one's a little bit kind of harder to see. Now, the problem here is I've got 2 different facts stored here. I am storing information about my physical copy. What condition is it in? Probably the main thing I'm trying to store here. But I'm also storing information about that conceptual book. Who wrote To Kill a Mockingbird? Someone just tell me. That'd be great if someone knew. Harper Lee, excellent, good for you. Harper Lee is, if you flash your mind back to a prior slide, you see it, author number 1025 is Harper Lee. And so I'm storing information about the conceptual book and about the physical book kind of commingled here. And let's say that in our environment, when we get rid of one of these physical books, we actually take it out of the database. It's unusual in today's day and age that we delete something. But in this case, let me go ahead and just remove that record. Now, this is called a delete anomaly because I had to get rid of the record of my physical book. Now I have lost the fact that Harper Lee wrote To Kill a Mockingbird. Right? So I've got this kind of different kinds of data about a conceptual book and a physical book stored here on one record. And now by deleting one that I have to delete, I've lost information that I otherwise was storing.
So we're assuming that we don't have a separate table that explains.
Yeah, we're assuming that there's not a separate table out there that says Harper Lee wrote To Kill a Mockingbird. Okay. This is what a delete anomaly is. I'm deleting this record and some other information that I was kind of depending on that record to know is now gone. That's information I'd still like to have around. And let's look at an insert anomaly. So let's say, we've got Toyland written by Stephen King, same ISBN number, but now one of them is coming in as paperback and one of them is hardcover, kind of the same thing where I've got, it's the same problem that happens over here, when I changed the title of Green Eggs and Ham, and that was an update. But now this is an anomaly where I've got kind of the same thing. The functional dependency tells me that ISBN determines the format. And because I inserted a record, I've now kind of violated that information from the functional dependency. And so this is called an insert anomaly. And those are the three main anomalies that we're kind of worried about with normalization. Insert, update, and delete anomalies. Question?
So that like the anomalies wouldn't happen in the original table we had, or just they'd be easy to catch?
Say the question again. The anomaly is,
So like, are the anomalies, they would only happen under the circumstance where we add that primary key, or like they would happen anyway, or they could happen anyways, but we could detect them easier.
oh, yeah, it's not, yeah. So the question is this all because we made this composite primary key, or we made this the simple primary key? And the answer is no, it's because we had the same problem back when this was a partial dependency. So even back when it was not in second normal form, we had the problem. Because for a given ISBN, there was two places to write the title. Now we've put this into second normal form, and I'm pointing out the problem is still here. It's a different problem now. Because there's only one column in the primary key, it can't be a partial dependency. So is this table in second normal form? It is. But all we've done is we've traded off all of our partial dependencies for transitive dependencies, which is what we have to get rid of to get into third normal form. And so by making a single column primary key, yeah, it's in second normal form, but all we've done is push the problem down the road. Does anyone say, well, the database isn't in third normal form, but it's in second normal form, that's good enough? No one ever says that. We want to get to third normal form at least, and maybe we want to go higher, but no one ever says, yeah, second form, it's second normal form, yeah, we're good. Yeah,
So there are higher levels than third.
there are higher levels than third.
Are we gonna have to learn those?
Fourth normal form.
Okay.
You guess the next one?
Eighth.
No, I've never heard of eighth normal form. There is, and actually the normal way they go is there's a thing called Boyce-Codd normal form, which usually comes after third normal form. Then there's fourth, fifth, and sixth normal form. There's some others that have some names, other kind of strange names, I don't remember. And no, in this class, we're not going to go anything past third normal form. Okay. So yeah, congratulations, we're in second normal form, but we haven't really fixed anything. So there's a principle here that underlies both second and third normal form. This is the principle that a given fact in the domain should only be recorded once in the database. So what do I mean by given fact in the domain? The title of an ISBN with a particular ISBN is your title, right? That's a fact. The format of a book of that ISBN is hardback. The condition of copy number 1 of that ISBN is excellent. These are all individual facts that we want to say, those should only be stored once. The author of To Kill a Mockingbird is Harper Lee. That should only be stored once. Stephen King lives in Maine. These are all facts. So let's take a look at this one. The title of that ISBN that ends in 5 is Green Eggs and Ham. So here, title of the ISBN that ends in 5, we've recorded this fact twice in the database. The title of that ISBN is Green Eggs and Ham. The title of this ISBN is Green Eggs and Ham. We've got 2 places to record that fact. That's the underlying problem here. So getting us into second normal form and third normal form is to say we want to make sure that any fact in the domain is recorded only once. So let's take a look at the right way to build this. What we're going to do, the correct solution is going to be to move the partial dependencies to a new table. Okay, so my partial dependencies were which ones? Author ID, title, and format. I'm going to pull those out, and that's going to leave you with copy number, ISBN, and condition.
Oh.
Copy number, ISBN, and condition. Those are here. Condition is not a partial dependency. It depends on both, right? If I know the copy ID, do I know the condition?
Yes.
Copy number, do I know the condition? No. Here's copy number 1, that's excellent. Here's copy number 1, that's good. Not dependent there. If I know the ISBN, do I know the condition? No. Here's, these first 2 are the same ISBN, they have different conditions, right? Because we're talking about physical books here. And so this one really is dependent on the combination of this, it stays. But my other 3, author ID, title, and format, are now going to come over as a new table. And so you'll see that, so not only have I brought the partial dependencies out, I've brought their determinant out as well. So what determines those? In fact, all three of these have the same determinant. They come into their own table. If I had some other partial dependencies in there on a different determinant, they would go into their own table. So whatever is determined by the ISBN is going to come into its own table. So we can kind of see that we've got them, we're doing the reference here. ISBN in the one table is going to reference ISBN in the other. And we've got, so we've got this one that maps to 2. Well, this is How the Grinch Stole Christmas. So different ISBN, and we've got the fact here that says this particular ISBN has a title, this particular ISBN has a title. That to be recorded twice is okay. Questions? Okay. So now all of the attributes that we have, I didn't really show it to you, but remember we used to have 2 records for this ISBN, but what we've done is we've collapsed those 2 into a single one, right? So instead of saying this ISBN has 2 places to put the title, we're now saying because ISBN is the primary key, there's only room for 1. And when we have to split over here to get the condition of the physical book, we're getting that with our condition, but that's happening in a different table. So because now our information only depends on the whole primary key, we haven't eliminated, but we're only second normal form. By the time we get to third normal form, we will have drastically reduced those anomalies, maybe even eliminated them all. But we're headed in the right direction. This is second normal form, and this is how you do it. You say, oh, we've got a partial dependency, pull the determinant and the dependencies out, pull the dependents out, and then copy the determinant over. So we've got to leave the determinant on both sides, but all the dependencies that come. Okay, so to be in second normal form, you got to be in first normal form, and you got to have no partial dependencies. If and the way you remove the partial dependencies is make a new table with a determinant, move the dependent attributes to a new table. The determinant's the primary key. Questions on second normal form? What do you think? Tell me where you are in second normal form. 0 to 5. So 4, 5, 5, 4, 4, 4, 4, and 5. Good. Okay. Let's take a look at third normal form. The relation is in third normal form if, can you guess what the next part says?
It's in second.
It's in second normal form, and it has no transitive dependencies. Transitive dependency. Transitive dependency exists when a non-key attribute partial dependency, a non-key attribute depends on part of the primary key. Transitive dependency, a non-key attribute depends on another non-key attribute. So you remember that when we had the naive solution to the second normal form problem, the naive solution form, the reason that this is not satisfactory is because it just converts the partial dependencies into transitive dependencies. So yeah, second normal form, yes, but it's going to totally violate third normal form. So you'll see then that we still have the issue where now we've got title depending on ISBN. ISBN is just not a part of the primary key, so it's not a partial dependency. We'll look at it and we'll say, well, title depends on ISBN. ISBN depends on ID, so this is a transitive dependency. See where the term comes from? Transitive dependency. Title depends on ISBN. ISBN depends on ID. By the way, does title depend on ISBN? Does title depend on ID? Yes. It does, because remember the primary key determines everything else. So everything else depends on the primary key always, but it really depends on it through another one, which is why it's called transitive. Okay. So does the ISBN determine the title? This is the primary key in this table. It determines everything. So for a given ISBN, it's the primary key. There'll be no duplicates here. So it totally does. In fact, I'm not quite sure. I just said I'll hit the back instead of the forwards. So yeah, ISBN determines title. Why am I even asking? Oh, just look at the other way. Does title determine an ISBN? No. I've got 2 different copies of How the Grinch Stole Christmas, 2 different conceptual books, How the Grinch Stole Christmas, and they have 2 different ISBNs. Why?
Because there's a hardback and a paperback.
Yeah, one's hardback, one's paperback. Now here's what I really want to take a close look at. Does the title determine the author ID? Now, in this case, there are some books that have multiple authors. For our domain, we are not considering this. These are only going to be authors with books with a single author. Perhaps we'll do another example later in the semester where we kind of look at multiple author books and how that makes things more complex. But in this case, then, does the title determine the author ID? For a moment, let's assume that we have no two books that have, no two different books with the same title. For the moment, let's just say. So if you think about the book and you say all the text in this book has a title, if there's another book that has that same title, it's got the same text. So under that assumption, then yeah, we're going to say that for a given title, there's only going to be one author. We got 3 different copies of To Kill a Mockingbird. These are 3 different conceptual books. Meaning that they have different number of pages. Some are hardback, some are paperback, and we can have multiple physical copies of each one of those. That's okay. So, does title determine author ID? Yeah. So you'll notice the title depends on another non-key attribute. I'm sorry, I said that backwards. Author ID depends on another non-key attribute. And so this is a transitive dependency. By the way, does author ID determine title? No. The author could have multiple titles. So we've got then a transitive dependency here. Does the title determine the year? This is, by the way, this is like the copyright year. This is not the publication year. Does the title determine the year?
Yes.
How the Grinch Stole Christmas is 1957. That's when it was made. To Kill a Mockingbird. Even though these are a different number of pages, the year here is like the copyright year, or it's the year written, rather than being like the year that this edition came out or published or something. So in this case, we're going to say, yeah, the title determines the year as well. Does the title determine the format? Yeah, so we can look here To Kill a Mockingbird, 3 different ISBNs, To Kill a Mockingbird, they've got different formats. So it does not determine the format. How about the number of pages? Does the title determine the number of pages? We've got different numbers of pages as well. Okay, so if we're to kind of look at the simple dependencies that exist in this table, ISBN is the primary key. So it determines what? It determines them all. Then we also identified that the title determines the author ID and the title determines the year. And so, and this is just another example, title ID depends on, author ID depends on title, which depends on ISBN, the transitive nature of it. So these are both what we call transitive dependencies. We got to get rid of them. Third normal form, second normal form, and there's no transitive dependencies. Good news, the solution here is exactly the same solution to the partial dependency. What was the solution in partial dependency? New table. We take out the dependence and we make the primary key the determinant. It's exactly the same thing for a transitive dependency. So it's the same process, whether it's a partial dependency or transitive dependency. So we're going to take our 3 transitive dependents. We've got a year. We're going to move it to a new table. We've got the author ID. Move that to a new table. And then what's the determinant? Title is the determinant. It's going to stay in both because that's how we're going to make the link. Now, notice here that we've got, and I'm going to call this work. So we've made a new table here. I've called it work. So you're going to notice that we've got now duplicate rows. We can't have duplicates in the primary key. And so we're going to be collapsing those. This To Kill a Mockingbird, we'll be collapsing those down. And so now we've got this work table collapsed, right? So we should be able to look at kind of, how the primary keys reference the foreign keys. Same thing we've done before. We've got 2 conceptual books with the same title. So now title is the primary key of this table. So these are both How the Grinch Stole Christmas, which means they both have just one author ID and 1 year. There's now only one place for me to record the fact that How the Grinch Stole Christmas was written by Theodore Geisler. Only one place for me to record that How the Grinch Stole Christmas was written in 1957. Questions?
Then
Yes.
This is stuff you'll definitely be thinking about. We will be thinking about now as we do our entity relationship diagrams, long before we're actually making the tables, right?
So you're going to be thinking about what you're going to think about while you're doing your conceptual modeling, whether it's entity relationship or UML class diagrams. The rule that you're going to say is, I want to make sure that as I'm modeling this out, I'm not storing the same fact twice. So you're not going to have to think all the way down to, oh boy, is that a partial dependency or a transitive dependency? Don't worry about that. Just make sure that you're saying, as I'm doing this, I'm not storing the same fact twice. David, you had a question.
So then title becomes a foreign key for, right?
Yeah, title here in conceptual book references the work table. So this is title's a foreign key. You may be uncomfortable with title being a foreign key. In fact, that's the next question. Can the title really identify the work relation? If the answer is yes, then we're done. If not, we got to go back to the drawing board. Let's take a look at this book. One of the books in our table is called Joyland, written by Stephen King. I don't know if you're like a horror fan. I am not. I prefer to sleep at night. And so I've never read anything by Stephen King. Although I get the sense this is more of a crime thing than it is a horror. But it turns out we got another book called Joyland, written by Emily Schultz. So the author ID here, 1031. The year this is written is 2013. Different author ID, 1026. Year is 2006. Now, it turns out that if Stephen King had written his book first, and Emily Schultz, I think this is her first novel, Emily Schultz said, I think I'd like to call this Joyland. What would her publisher say? There's no way. You're not going to name the same thing as some other book, that's out there, especially one by a really popular one. Assume it's popular because Stephen King wrote it. But that's not how it happened. Emily Schultz said, I'll call it Joyland. Her publisher, great. No one's ever called a book Joyland. That's a great title. Stephen King comes along now, 7 years later, and writes this book, says, I want to call it Joyland. What does his publisher say?
Sure.
No, his publisher doesn't say sure. What does his publisher say when Stephen King, I want to call it Joyland?
There's a book. with that.
It's a really bad idea because there's this book, it was written 7 years ago called Joyland. What does Stephen King say?
I don't care.
Stephen King says, I'll find another publisher. Then what does the publisher say? Joyland it is, right? I mean, that's how this works. There are very, very few books that have the same title. And it's kind of for that reason. And really, it is so few that you might say, what, title's enough, and just hope we never have to record Joyland written by Emily Schultz or something. But in this case, we're saying, no, it's not enough. Okay, so we've got a new record in here, a real record called Joyland, published in 2006, hardcover, this number of pages, different ISBN, different author. So now, does title determine the author ID? No, it doesn't. Okay. We still got the problem. Title is not the identifier. Do we still have transitive dependencies here?
Yes. But not with that particular one, but with the other ones.
Yeah. So here's the question. We're still, now at this point, we're thinking a little bit beyond just looking at one column at a time. What we're saying is, remember, we identified this thing as a work. We're saying that a conceptual book is like an implementation of a work. So if I think of How the Grinch Stole Christmas, conceptual book is exactly how is the font laid out. The work is the same. How does it start? Who down in Whoville liked Christmas a lot, but the Grinch, who lived just north of Whoville, did not. That's the content. That's the same for the work, regardless of how it's laid out and printed. An ISBN is how is this laid out, formatted, and printed. And so we've got two different things, and we're storing information about two different things in the same table. That's what the fundamental problem is. And so we're storing information about the work along with the implementation of that work, which is the ISBN. So we still have that issue. So now, what we either should do is find a set of attributes that does show me the functional dependency, or maybe we should use a surrogate in this case. But let's see now what this functional dependency is. So a little more complex, but does the title and the year taken together determine the author ID?
Well, in this case, yes.
In this case, yes. Now, what do you think? Do you think that in the book industry, the title and the year determines the author? I think it probably does. You only need one counterexample, but in the world of publishing, they really dislike having two books with the same title. Yeah, could it happen? So you might be uncomfortable with it, but let's explore this. Let's say, yeah, you know what? It really is. We're saying, we're not going to allow it. So let's take a look at what we have to do. It's just now, what's the rule? You know what the rule is? So if I've got a transitive dependency,
Take out all the dependents, put them in one table, and then take out the determinant and make that the primary key.
you said that exactly right. Take out the determinants of the dependents, put that over as the attributes, and then take the determinant, make that the primary key. So how many dependents do I have now? Yeah, so now author, it used to be that we said author ID and year depends on title, but now we're saying, no. Author ID depends on year and title. And so let's go ahead and look at this using a composite identifier. We're bringing the author ID, making it the attribute of the table. And we're bringing the dependent, and we're bringing out the determinant, taken together, title and year. That's going to be the primary key. So now we're referencing not just one column, but two columns to be able to make the join. Question?
So is that the same table as before, but now we're just saying year is part of the composite primary key?
This is the same table we had before. We're just saying that now year is not an attribute. It's not a non-key attribute. It's a key attribute, part of the primary key. But the difference is that that means we have to leave year over here in the conceptual book table to be able to make the reference.
Because
That's the difference.
you need both.
Because to identify a work now, we need the title and the year. And you see that for Joyland, even though it's the table's in the way here. To identify Joyland, I need the title and the year. Question?
And in this case, it's the title and the year together that are the determinants for the author ID.
That's what we're saying, is that the title and the year together is what determines the author ID. And so, yeah, so it's a little more complex because it's not just as one column by itself determining other things, but you have to say, taken together, these two really do determine these others. So we're now in third normal form, but what do you think really about using title and year to identify a work? Does that give you any heartburn? Are you uncomfortable there, David?
Like we could throw author ID into somewhere else, but I'm trying to figure out where.
Well, let's look at the other option. Oh, go ahead.
We just make like a work, another column in work, like.
You're talking about making a surrogate identifier.
Yeah, that.
Make an identifier that you just make up. Yeah. So here's that exact solution. Is what we're saying is let's just give a unique identifier to the work. Don't try to identify the work with composite, title, and year. Let's just say, you know what? You got Green Eggs and Ham? That's work number 1000. You got Joyland, written in 2013 by Stephen King? That's number 1002. Seems a little strange that number 1002 was written after 2003. I probably should have thought about that example better. I mean, the one that was written in 2006 probably should have a lower number, but we're here with these now. So it's just some arbitrary identifier that says that's what uniquely identifies it. So in this case, we don't need to leave the title over here at all. Title now becomes a non-key attribute, and we've got work ID that we're using to make the reference between the two tables. Okay, so what do you think? You like using the surrogate now as the identifier here?
Yeah.
The real question is, am I really trying to enforce that no title, that no two works can have the same title in the same year? If I'm kind of looking at it and I'm thinking, I could probably get by with that, that's different than saying that's a constraint I'm trying to enforce. If it is a constraint I'm trying to enforce, leave them together as the primary key. That lets you enforce the constraint. If you're saying, I'm a little uncomfortable because maybe, who knows, but one day we might. I'm not trying to enforce it. It happens to be that it identifies it. I think you're probably better off with a surrogate key. Question.
How could you explain how that's different from when we were talking about second normal form and we made our own little primary key and that created a problem for third normal form?
So why is this different? So the question is, if we were to roll the clock back to the naive solution, a long way back.
Yeah.
Gosh. Oh, here it is. I hope I'll be able to get back to where I left off. Why is this different? It sounds the same. You're just making up a new key. And the reason is because when I do it here for second normal form, I've already got these what were partial dependencies before. I'm now just converting to transitive dependencies. Over here, when I'm doing it in third normal form, then I've already split out a different kind of thing. The conceptual work now is what I'm using to split this out. And so I don't have the ability to store the same fact more than once. I'm not sure that I really answered that question with exactly the right words. But the result is, when I'm doing it here, I'm not ending up with the ability to store the same fact twice.
I think that makes sense. Is it also that we've, like, this table already doesn't have any transitive dependencies?
So this table doesn't have any transitive dependency. We can just look, does any one of these things determine?
No.
Oh, well, here's the question. So before, what we were saying is that taken together, title and year determine the author ID. And what we said was we were uncomfortable with that because we think that probably really isn't true in the domain, even though it's true in the data. It probably really isn't true in the domain. We think that maybe there might be one there. And so by going this way, we have declared that that is not a functional dependency. That taken together, title and year does not determine the author ID. If it did, then this is the way that we should do it. It really is something that we're trying to enforce in the domain. Probably go ahead and leave that. Alternatively, we could go this way, and then we could put a separate constraint onto the table that says, by the way, title year has to be unique. So taken together, title and year has to be unique. You can put additional uniqueness constraints apart from the primary key onto it. And the nice thing is that if we did that, and maybe we thought, it really is, we think it is unique. Well, but we're not sure it's always going to be unique. We might design it this way because we'd say, we can handle non-uniqueness. But let's go ahead and enforce a constraint that says taken together, title and year is unique. Because then when we realize, oh, what, new book, no longer unique, what do we have to do? What do we have to do if this is how we did it?
We have to create a new.
Yeah, this is no longer primary key, no good. We've got to do this. But if we've already done that, we've enforced this constraint. It's just a matter of moving one constraint off of one table. Say we used to enforce that there was no duplicates among title and year, and now we're not enforcing that anymore. Now we've seen the counterexample, and that's the only change we'd have to make in the implementation. Other questions? Yes.
So for example, the problem would be like if two people, different authors, wrote the same book in the same year, then that would no longer work and we would need the work ID.
Right, if we're over here and we said, you know what, we have never seen where a title had the same name, two books had the same name and were written in the same year. And so, and we've got enough experience here that we think they're so rare that we have two books with the same title even, that we're comfortable using that. And then all of a sudden in 1 year we get, oh my gosh, there's a book we never knew about. Or in 2022, two publishers publish a book with the same title. Do they coordinate among each other? How come this hasn't happened?
That's what I was thinking.
I had my next door neighbor, when I was a professor at Tulane, wrote a book about, this is probably before you could remember, but there was a sniper in Washington, D.C. Hiding in the back of a trunk, and he was just killing people randomly.
Yeah.
And she wrote a biography of him. And she wanted to call it The Invisible Man. What did her publisher say?
No,
Because
because
taken. So how about just Invisible Man? Just not an invisible man, not just the invisible man, just Invisible Man.
maybe.
Already taken. How about an invisible man? An invisible man's available. That's what she called it. But yeah, I mean, so they really do, kind of enforce this stuff. Okay. Surrogate, okay. So remember that the normal forms are cumulative. So can't be in third normal form unless you're already in the prior normal forms. So a relation is in, and these are the rules. A relation is in first normal form if all of its attributes are atomic. That's first normal form. A relation is in second normal form if it's in first normal form and has no partial dependencies. Third normal form,
Transitory.
no transitive dependencies. So it's in second normal form and has no transitive dependencies. That's it. That is first, second, and third normal form. Show me on your hands, 0 to 5. Where are you? 5, 5, 4, 5, 4, 4, 4, and 5. Excellent. That's what I want to say. So, we probably should have an oath. So doctors take the Hippocratic Oath. I don't know what the Hippocratic Oath, but something first do no harm and so forth. So we should probably see some kind of like data professional's oath where you say, I swear to organize tables such that all attributes depend on the key, the whole key,
But the key.
nothing but the key. So help me God. Not that many jokes in normalization, so you gotta take what you can get. And that really it is. Now, this is not first, second, and third normal form, right? First normal form is no multiplied attributes, but this really is the whole key and nothing but the key, second normal form, third normal form. So think that it's got to depend on the key, the whole key, and nothing but the key. Why didn't you just put this slide up at first and dismiss us? We could be home eating bread by now. All right, any questions? David?
So I know you said we're not gonna learn the other ones, but
Yes.
is it common to use the other ones? Or is this like, if you're crazy, you can use but like you have to use them?
Yeah, so the other normal forms, the truth is I couldn't even describe the other normal forms to you. Generally, in practice, we say if you're in third normal form, great. Are there situations where the other normal forms would be important? And the answer is probably. Some of the normal forms are like, if you look at the third normal form, no transitive dependency. What's transitive dependency? When a non-key attribute depends on a non-key attribute. But what if you had an attribute that was a part of the key depending on another part of the key? It doesn't violate second or third normal form if you've still got the same fact recorded twice in the database. If you've got these keys where you've got functional dependence, partial dependence, it's not even a partial dependency because a partial dependency is a non-key attribute. You've got these weird dependencies happening inside the primary key. Because in fact, if you just make every column the primary key,
Yeah.
so some of the higher normal forms are like saying, okay, that idea that you had about making every column the primary key, cut that out. It's normal form or something. So yeah, there's deal kind of with weird things. Normal form is going to serve you well through your career. Other questions? All right, one last question. Yeah,
Audio recording?
I dearly hope so. You guys are going, maybe it's not recording. He's going to have to record again. He'll bring more bread. All right, thanks for coming, folks. We'll see you.